All right, now we're going to take a look at inverses. So for most students, or if they randomly got form A, this became a problem number 16. Let's say you're looking at this problem and you see if f of x equals 8x cubed, which graph represents f negative 1 of x? And let's pretend you don't remember what this symbol means. You're looking at that and you're going, man, I don't know. What in the world does that symbol mean? Well, here's what I recommend for you. I'm going to close my Desmos from the previous problem. What I would recommend is you go to this Desmos graphs list, this table, and you look down the symbols column. Because if you look down this column, you will see a symbol that looks like f negative 1 of x. What number, and what I mean by number is on the left side here, what number do you see f negative 1 of x on?
6.
So over here, oh, not quite.
5.
5. I thought I was 6.
That's fine. Number 5. I know it's a lot smaller on your end than it is on mine. So we're now going to click on that inverse graph. So I'm going to click this, and I'm going to pause the video. And I'd recommend if you're watching this later on, not live, just pause the video until you get this open yourself. All right, so now hopefully you have your inverse graph up. So what we do is we take this f of x equation and we plug it in right here. It says graph the original function f of x as it appears here. So I'm going to say 8x cubed. 8x cubed. Ooh, and I just realized I need to update something on this. This gives a restriction. This problem does not have a restriction. So right now the graph doesn't look right. You only see half of it. I need to change this to a negative infinity. I messed that up. Negative infinity. There we go. I'm going to do it like that. Now, when you look at your graph, the blue is the inverse. So this says like this. Note, restrictions to the domain can be entered by adding a restriction after the equation. Oh, I forgot to delete that. So that needs to be gone too. I need to update this graph. So I updated it yesterday to make it more user-friendly. I need to change it. So here's the instruction I wanted to read. The graph of the inverse will appear in blue. So there's the inverse. So now all you have to do is find the one that matches the blue. So which graph, F, G, H, or J, matches this blue graph?
F.
F. So F's the correct answer. So we did that problem in a matter of seconds just by plugging that in. The one thing, like I said, I'll update this here shortly. The next time you do a DOL, I'll change this so you won't have to worry about that restriction being like that again. But F is the correct answer. Now, if you want to do the algebra, if you remember, the algebra way that we learned earlier in here is you switch your x and y. If f of x represents y, then to solve for an inverse, let me write that here, switch x and y. So what I would do is I would just say x equals 8y cubed. Okay, so if I say x equals 8y cubed, I would solve for the y now. So after I swap them, I'm going to solve for y, which I'm going to divide the 8 out. And then the way to get rid of a cube is you do a cube root. A cube root is this thing that looks like a square root, but it has a little 3 right there. And that's what would cancel the cube there and the cube root. So that goes away, and so what you're left with is that y equals the third root of x over 8, or you could rewrite, instead of saying y, you could use this symbol, that f negative 1 equals the third root of x over 8. That's the algebra, and if I type this in right there, the third root, I think, is under functions, then you go to miscellaneous, I think. Yeah, there it is. So I went from the keypad on Desmos to miscellaneous, and then it's the middle column, third from the bottom. You click that button, you can type the third root of x divided by 8, and you'll see that that does match. And unfortunately, it used the same color. Let me go to blue, or I'll do black so I can go off and on. So now you can see that this does overlap the blue perfectly. So the calculator did our work for us. So again, that's the easier way of doing that. Okay. Now I have 3 of these to show you before we do our next duel. So let me show you the next 2. So there's number 16. Here's number 41. You're about to learn why I did this restriction over here. It says if the domain of f of x equals 2x squared minus 1 is restricted to this, which graph represents? Again, that's the inverse symbol. So what we'll do is we'll go to f of x and type in 2x squared minus 1. 2x squared minus 1. The original, it says, is red. So the red is the original. The blue is the inverse. But right now, none of them match. And that's because we haven't put this restriction in. So now you put in the restriction. What the bracket means is that you need an equal sign underneath here. The comma represents where the x goes, and the infinity is on the right. So this is what we called interval notation earlier in the year. Intervals where you use brackets and parentheses. That's interval notation. Unfortunately, Desmos does not understand interval notation. It's kind of like many of you might be able to speak Spanish, and I don't know what you're saying. You know one language, and I don't know what it means. Desmos is like me. It only understands one language, and it's the inequalities. I only understand English and math. You understand maybe English, Spanish, math, maybe other languages. You're multilingual. Desmos is not. Desmos only understands those symbols. So you have to change them. So I'm going to come over here and change this to a square root. So square root, the normal square root is on the keypad, just the normal keypad down near the bottom. So square root of 2, and I need to divide that by 2. So when I type in the restriction now, it shows me an accurate graph. So the blue starts on the y-axis. So I'm going to come over, I'll eliminate the ones that do not start on the y-axis. Those 2 are gone. So it's either going to be A or C. They're very similar, but I see this one's like looking a little bit higher. This one looks a little bit lower. So I'll find just a good point. So this one, I see a good point right there if I look closely. That has an x value of 3. It's 3 to the right, and it looks like it's 1 up. Over here, the first good point is right away right there, which seems to me to be 1 unit to the right and 1 unit up. So what I'm going to do is I'm going to go to the graph and see where's that good point. Is it at 3, 1, or is it at 1, 1? So when I come over here, it shows it to me. It's clickable. It's at 1, 1. That's the good point, which means C is the correct answer on this problem. Okay, I'm going to do one more. And I forgot to copy the multiple choice. Hang on, I'm going to pause this just for a second. Okay, now let's try the last one. This one says if f of x equals this equation, what is f negative 1? And kind of like that one problem we had a little while ago of compositions, this one they only give me equations. They don't give me a graph. They don't give me a number per se. They give me these equations. So here's how we're going to do this. It's going to be the same concept. So I'm going to first type in f of x as being 3x. Slide this over so I can see it better. 3x minus 1. Oops, I forgot to the divide. If you forget, if you hold down the shift key and highlight everything, you can press the division symbol and it won't erase it. It'll just make that whole thing become the numerator. So then 2x plus 3. So there's the equation. Now this problem doesn't say anything about a restriction, which means on my restriction, I need to put this to be negative infinity. So I'll hit the negative key and I'm just going to type in infinity. I learned just yesterday. I didn't know that there is an infinity symbol on Desmos. I'm sure the symbol's somewhere. I don't know where the symbol's located. I have no clue. But if you type in infinity, it'll put one in there for you. So I changed it to where there is no restriction whatsoever. So if it doesn't show restriction, it needs to be negative infinity to positive infinity. And it won't matter on the symbols if you put the equal to or not. It'll still graph it just fine. Okay, so remember the red is the original, the blue is the answer. So what we did on the previous problem that did not give us a graph is we just graphed the answer choices and saw which one overlapped. And that's what I'm going to do right here, is I'm going to graph these answer choices and see which one highlights the blue or overlaps the blue. So we'll just type them in. The first one is, I'll hit the division symbol first this time to be easier. 3x minus 1 over 2x plus 3. Now, did that overlap the correct graph? It overlapped a graph, but is that the correct graph to overlap?
No.
No.
The original. So it's not that one. That one's wrong. By the way, this is a restriction. So I don't know if there's a does not equal symbol, but that's what that restriction would be if you wanted to add it. I don't know if there is one like that. I'll have to play around later and see. Okay, let's try part B. Negative 3x minus 1 over 2x minus 3. Does this overlap?
Yeah.
Yeah. So this one's going to be the answer right here. Oops. That's going to be correct. I'm going to go ahead and work through. Oh, wait a minute. I just realized these two are the same equation, aren't they? See how these two are both the same equation? Okay, we got to figure out which one's the restriction. So at the moment, I didn't realize that. Both this equation is correct. These are the same things. And this one's correct. I had no idea. These two, notice, are also the same. So the only thing that's different is the restriction. We have to see which restriction is accurate. And I'm going to let you figure this out by me typing this in. So we know that these two are the right equation. These two are the wrong equation. But that we've already established. So now we're going to look at the restriction. And I'm going to type in, I don't know if there's a does not equal, so I'm just going to type in the x equals. And I'll let you see if you can figure out which one's the correct answer. There's x equals 3/2, and here's x equals negative 3/2. Now I'm going to let you look. So the two options. Here's one option, the purple. The other option's here, the black.
Do we tell you or text?
Yeah, which one do you think is correct?
I think it's the 1.5, the purple one.
Okay, you are correct. It is the purple one. Why is the purple answer the better choice as opposed to the black answer?
The purple one is showing you like where both the graphs are.
Yeah, the purple one shows you where the green graph, which is the answer, is divided. What is the black one showing you?
The graph before the inverse.
Where the original divides. The black is showing you where the original divides. The purple is showing you where the green divides. So to tie this together, you see how this symbol actually over here is saying does not equal? I typed in does equal. I typed in the opposite symbol. What the purple is showing you is the one spot where the green does not exist. The green doesn't exist in the middle. It's not there. That purple with the opposite symbol would fill it in. But again, it's the opposite symbol. This is saying it does equal. This is saying it does not equal. So what it's saying is that one spot right there is where the graph divides. For that reason, this is the correct solution right here. Whoops. This is the correct solution. This one becomes incorrect because it's not breaking in the right location. So this is the correct choice. So that was a little tricky there. I didn't even realize that in the answer choices. That was really tricky. I bet the data is not as good on that one because that's kind of a tricky problem. Let's look. So we just did 3 inverse problems. The data for the first inverse is we got that right about half the time. That was the first one. The second one we got right. Ooh, only a quarter of the time, which is basically just a guess. If it's multiple choice, 25% would be a pure guess. So that's just about a guess. And number 5, we only got correct. Yeah, 24% of the time. That means those two were guesses. So hopefully now we know it better than a guess. We might not be experts yet on this part, but hopefully now we're better than a guess. We at least are 50-50. So with that, I'm going to see your data. I'm going to give you the next DOL, and we're going to see what your data is for this one. So come over, back over to your, this problem, and I want you to open up number 2 now. And I want you to work on this problem.